when?
Start.
Start? Okay. So we have evolutionary neurophysiologic-based adaptive cruise control with speed.
Sign detection and driver assistance.
Okay, long title,
Yes.
but what I understand is it has to do with real cars driving, and you have automation coming into that.
Yes. So
Explain to me.
three main parts: the adaptive cruise control portion, speed sign detection, and driver assistance. The adaptive cruise control portion basically controls how the car reacts with another car in front of it. So suppose we have a distance sensor in our car, and the car in front performs an unsafe action such as swerving in front or stopping immediately. Our car should react appropriately and slow down or stop to avoid the collision. The speed sign detection portion of the project focuses on when we're driving along the road, we notice a speed sign along the edge of the road. Suppose we're going at 80, we detect 60, we want to notify the driver saying you're slow down within the speed limit to 60. It's a warning system to avoid speeding tickets or unsafe actions that may occur from driving too fast.
See, if I have a car I'm driving, right?
Yeah.
And I have this equipment installed with the software, everything.
Yep.
And so every time I try to go over the speed limit, what happens?
You have always the
Driver
final
always has
control.
the main control no
So you
matter
get,
what.
as soon as you press your foot on the accelerator,
Yeah.
you take over control.
Okay, but if I put it on cruise control, what is it doing?
Cruise control, it'll give a warning basically that you're going too fast
Okay.
over the speed limit.
Okay. Cool.
Yep, and the final part is the driver assistance, which basically detects whether if you're going outside a lane or if you're swerving outside the lane. So suppose you're on a highway and you swerve outside the lane onto the shoulder, it'll give a warning saying you're driving on the shoulder. If you're not indicating, it'll give a warning. Or if you're performing an unsafe action such as swerving into another lane, it'll give a warning as well.
So tell me about the sensors. Like, how many sensors do you have? Where are they placed on the car?
Currently, we're using a distance sensor to just measure the distance
Distance
between
sensor?
our car and the car in the front.
Okay.
And we're using camera to detect the speed signs,
And
detect the lanes and traffic light.
Traffic lights is basically for driver assistance. So if you detect a traffic light, which is red, you want to notify the driver if they're driving too fast. There's a red light approaching, you might want to slow down a bit.
It reminds me of the project called Google self-driving car.
They have it, yeah. They have license.
Yeah.
They're licensed in Nevada.
Yeah, they have passed a bill in California,
Yes.
so it's essentially a car, and it's doing like some of the things you're doing over here. So it's making sure it's in the same lane, it's driverless, it's stopping at
Yes,
red
and
lights.
it turns during the curves.
Yeah.
It
Yes,
follows the curves.
it parks itself. But this is what I'm guessing. Like this big project would be one of the modules of like controlling a whole car.
It's a combination of those three systems.
So
that I
what made you decide this area? Why not something else? Like, do you think is there a problem at the moment with drivers?
The thing is, there is adaptive cruise control technologies in cars nowadays, but they don't combine the three systems that I labeled before: the sign
Yeah.
detection, the driver assistance, and adaptive all together in one big system.
And speaking of problems, yeah, there is a lot of cases where drivers are not as alert. Sometimes they're tired, and sometimes there's chances they'll miss the speed sign. So this is basically this is promoting defensive driving and assisting the driver in making safe decisions while
It's an
driving.
enhancement to the driver itself.
Yeah, like I can imagine there could be a meter, like because I have my speedometer, right? And just beside that, I have like maybe a color code type of thing. If I'm driving too fast, I get a boom,
It'll give
like
a warning.
too fast.
Yeah, on the user interface, it will give a warning saying you're driving too fast.
Maybe a annoying noise.
Yeah, like in the,
Something like that.
We actually have a sound indication right now with the speed sign detection, but you can't hear it right now because of the.
Of the,
it says speed sign detected 80 kilometers an hour or 60 kilometers. Just an auditory notification to the driver,
Just to let the driver
So
know.
for reinforcement sake.
so how are you actually delivering this technology? Explain that to me.
Can you talk about the image processing?
For the image processing, basically what we do is we take the raw image that we get from a camera, mounted
Yes.
on the, and we threshold it, which is basically we analyze the part of pixels, and we take a look at the color and determine what is white and black out of the pixels. So as you can see, the speed sign is largely white. Then we apply morphological operations in order to extract all the rectangular objects out of the image. So these are all the rectangular objects in the image.
Yes.
And as you can see, we apply a ratio rule. As speed signs, their length and their width have a ratio of approximately 0.8.
Yes.
So these are all the possible rectangles, which could be speed signs. Then we apply another algorithm, basically to determine what is a speed sign and what is not.
So-
You're using neural networks for
Yeah.
to recognize the signs.
So one is like because the road, every road has a speed limit, and
Yeah.
it changes. Highway 100, in city 60. So this is determining the speed limit, number one. And then also, the technology you have shows me, allows me to keep in lane as well.
Yeah.
So what part is taking care of that?
And that
If we are still using the same threshold
Same
image,
threshold limit, okay.
then we are using the hope transform to find the lines.
Yes.
And the longest line is usually the lane.
yeah.
Okay.
Yes, we are not shown in this video, but
Yeah.
particular video, but
Okay.
we have this technology implemented too.
Yeah.
Good. Good. Did you guys test it on a real car and see how
Yes,
it
we
would
did.
go?
You
Tell
can
me
see the
about that.
videos there.
So that's the real car.
Yeah, the image processing, you can notice the green on the outside, and we get a notification at the bottom saying speed sign detected. So you notice the green area of interest right there, and then notification at the bottom.
So that's actually a real demo of the technology getting
Implemented.
reading
the speed sign and applying the algorithm as I mentioned before.
Now what's going on?
This is the simulation we have. It's the open source.
This is the car we programmed.
This is the car we program using open
It has
source
the artificial
software.
intelligence.
So basically,
Let's play it again.
yeah.
Since we were not able to control the real hardware card,
Yes.
so we implemented in the software.
You specified the width, the car,
Exactly.
the length,
The simulator specifies
It's real physics, basically engine of the car, collisions and tires and aerodynamics and everything basically put together. So it's as
Okay.
real time as we can get it to where it's a car. So what
Perfect.
this car is doing, the yellow car is in charge of performing unsafe actions. It's a regular car. It's any driver.
Yes.
The blue car is a fuzzy car which has our system in place in it. So as
Yes.
the yellow car performs unsafe actions such as swerving in front, stopping, our blue car will react accordingly with stopping or avoiding the accidents. You'll notice in the scenario coming up here, the yellow car stops suddenly, and we'll see that the blue car will stop as well and try to avoid the accident. So you'll see, it will stop right there. You'll notice the yellow car is stopped.
Wow. So, as a driver, if I'm careless in all these accidents, if I'm unable to react properly, the automatic system is taking care.
Of course, that's
Because it reacts much faster
as
than a
machine-
human being.
As a machine, it's an enhancement to the driver. It's supposed to
Yes.
react faster to the driver.
Really good. Wow. This is a superb project. Because it's using so many parts, like so many areas of engineering.
Yeah, it's a combination of everything to get the best possible result for safety. Safety is a primary concern for this project. It's adaptive cruise control.
Good. Good. What limitations do you have at
We
the
have a
moment?
real-time simulation.
Oh,
wanna see?
wow. Sure. Let's
So
take a look at
basically,
it.
you will be controlling the car that creates unsafe action.
You will basically be the yellow car in that
There's
case.
two cars on the track. One is the car we programmed with the artificial intelligence.
Yes.
Its job is to avoid collisions, and the other car is the one we're going to be control. We're trying to create unsafe actions and test the ability of our car and its fuzzy logic adaptive cruise control.
So, I'm a really bad driver. I'm
We
going to
also
drive.
coded
Oh,
a
it's-
small app for basically putting the road signs into it.
Okay.
So this is the road sign 45, 50, 60, 80.
Okay.
This will control the speed of the fuzzy
So
cruise.
tell me how to start.
So he'll start the program for you.
You have that's the accelerator, and that's the brake on the left side.
Okay. Accelerator, brake. and it's-
Brakes, yeah, and then the accelerator. It's a little sensitive, so you
Okay. I'll be careful. But let me see how well does my control system take care of me.
So you are the green car?
I'm the green car?
Yes, you're the green car, and that's the fuzzy car. So you're going to try to perform unsafe actions such as swerving in front.
Okay, slow the speed for you.
Okay, give me a speed limit. What's my speed limit?
You can go whatever you want. You can do whatever speed limit you want. Our fuzzy car will maintain the speed limit, whatever we set it to be.
Yes. So fuzzy car is maintaining the.
So now if you go right in front of it and cut it, so it's gonna.
We try to avoid you.
Good.
So
Perfect. It's avoiding me. Let's try that once more.
try a different speed.
Okay, give me a...
It's slow.
It's very slow. It's 45 kilometers an hour, so you can catch up to the car and then try to cut it. Try to cut in front or stop
Okay,
or brake.
because that car is not going to go above 45, the blue fuzzy
It's
car.
basically what we're simulating is the speed limit on the road itself through the app. That car will always follow the speed limit on the
Now
app.
go in front of it and slam the brake. Like this.
Wow, it avoided the collision.
Yeah.
Here you go.
Wow.
You can see all the
The speed.
interactions that this car.
Yeah, that's the output data, the steering, the acceleration.
Okay, let's do that one more time. You know, it's an awesome safety tool because I can see many practical applications of this. Like you can go talk to GM or
Yeah, that's one of the things we're looking towards in the future, perhaps commercialization with GM or Ford or some other project. The brake is actually the reverse if you want to reverse out. Yeah. So you wanted to hear some of the limitations of the project too, right?
Look, you know, I'm getting the concept. So,
Good driver.
thanks, yeah.
Not a lot of the guys who got in the first try on the 260.
Oh, okay. So, you know what's most interesting about this project is most of the accidents that happen not because of your fault, but like we assume it's because someone else was drunk, someone else was irresponsibly driving. And say I'm driving, I'm a nice guy, you know, I'm following all the rules, and someone tries to slam me or take a really tough takeover. It's automatically detecting it, and it like slows down or changes lanes.
And the interesting thing is, since you have the image processing there,
Yes.
if it ever came to an accident, you have video proof that it wasn't your fault.
Yes, so insurance companies could actually go to the truth now, right?
Yeah.
So it's
Okay.
it has a broad range of applications in that the image processing can actually update GPS with that.
So is it an electrical software project
It's a combination of multiple areas of
Tell me
Us,
your
us
area.
three are software engineering, and he's electrical.
Electrical, okay. Good. Cool. So, wow, I mean, so far this is one of the most interesting projects I've seen. You know why? Because it's like very deep and broad. It's not a small thing. It looks elegant, but it took a lot of work to get to this point.
We're looking to develop something new, you know, a combination of everything that we've seen before, but not together in one system, basically. Because we've seen adaptive cruise control, we've seen spine detection, but not together in one system. With the combination of all these systems, we're getting the best possible result-making engine that will perform the safest actions together.
Perfect. Lastly, I'll ask one question to you. You said how you can save the evidence in case there was a collision for insurance companies. Now, do you have any ideas on how you're going to maintain the data, like in a database, save it locally on the car?
Well, that would be, suppose you drive, like there are many cars like this, like once you drive, you plug them in and it stores the data on the cloud. So it would store data in those situations. But since you don't want to record, like let's say, all the time that you're driving,
Yes. What's
you
the
could
point?
implement into the system.
Every time there's a collision,
Yeah.
save that data
Yeah.
since the point of the collision.
Yeah.
Okay. Good. Awesome project. Good.
Thank you.
Awesome job. Did the judges come by?
We've had 3 judges so far.
Okay. I'm sure that's going to be good.